Alright, completing the square. So when you're completing the square, what you're doing is you're taking whatever equation you have and making it into a perfect square. So what we're going to do is we're going to find the perfect value of C by taking b divided by, not negative b, try that again, b divided by 2 and then squaring it. So b divided by 2 and square it. Once we do that, we will get our perfect value. So what we're going to do is first we're going to find the value that makes this a perfect square. So to make this a perfect square, b is negative 10, so negative 10 divided by 2 squared equals negative 5 squared, which equals 25. So c would be 25, which means the perfect squaring would be x squared minus 10x plus 25, which would make it a complete perfect trinomial square. So what does that mean? If I factor this down, it would factor into something squared or the same thing times itself twice. So this number here, what b divided by 2 is literally the value that it factors down to be. So this would be the same as x minus 5 and x minus 5. We do this so we can solve by completing the square or solve by using the square root principle or property. It's just another way of solving. So in here, 5 divided by 2 squared, cannot simplify this any further, so that becomes 25 over 4. So the perfect equation would be x squared plus 5x plus 25 divided by 4. And if I was to factor that into its perfect trinomial square, or the perfect square, it would be x plus 5 halves. So what does that mean? Well, we're going to solve this equation up here by completing the square. So what we'll do is we're going to make this into the perfect square. So x squared plus 16x plus something, which is that c value, is 9 plus something. So if I'm going to add something to the left side of the equation, I have to add it also to the right. This value that I'm going to add is just like what we did down here for the c's. So 16 divided by 2 squared equals 4 squared, which equals 16. So I'm going to add the value of 16 to each side, but what happens, I'll this down here just a little bit, is I'm going to automatically know what this factors to. So this side here, if I was to factor it, this would be my factoring value. So on the left side, I know it's going to x plus 4 squared. Wow, I did that wrong. Let's try that again. This should be 8. This should be 64. This should be 8. So this actually should be, and I don't know why it's not erasing. Let's see if I can fix this. 64 and 64. Sorry, computer's automatically trying to transition there. So now 9 plus 64 is equal to 73. Square root both sides. I'm going to add the square root in. Since I put the square root in, this is going to be x plus 8 equals plus or minus the square root of 73. Subtract 8 from both sides. My final answer is x equals negative 8 plus or minus the square root of 73. Anything with a radical or an I on it is in the second half of the equation. You can write it out as two different answers, but I like to just keep it as one. And unless we ask you to round, you do not need to simplify that any further. So this answer or these answers are sufficient. We'll come back to number 2 here in a minute. What we're going to do is we are going to jump to A, B, C, and E. And then we'll talk about solving with variables of a equaling 2, and then we'll talk about writing in vertex form for everything. So, this equation here, add 8 over, so you get x squared plus 2x equals 8. I'm going to have to add that magic number in on both sides. So 2 divided by 2, so b divided by 2 squared equals 1 squared, which equals 1. So showing work, x squared plus 2x plus something is going to equal 8 plus something. This value is this 1 right there. This left side factoring is going to come here. X plus 1 squared equals 9. Square root both sides. So x plus 1 equals plus or minus 3, because square root of 9 is plus or minus 3. Subtract 1. So x equals negative 1 plus or minus 3. I can simplify this, so negative 1 plus 3 is x equals 2, and negative 1 minus 3 is a negative 4. So there's my two answers. Okay, going to do B. I apologize for my auto-focusing. Let me see if I can change that setting here real quick. Nope, can't change that right now. So, we'll just have to keep trying to go with it. So move 16 over. It's really getting annoying now. So, let's see if this turns it off. So minus 16, x squared minus 8x equals negative 3. So, negative 8 divided by 2 squared equals negative 4 squared, which equals 16. So, on this left side, negative 3 plus 16. This side on the left side automatically factors with this, x minus 4. So I get x minus 4 squared equals 13. Square root both sides. I'll do this work over here for this one. Gives me x minus 4 plus or equals plus or minus the square root of 13. X equals 4 plus or minus the square root of 13. So this next one, move the 9 over, I get x squared minus 4x equals negative 9. Negative 4 divided by 2 squared gives me negative 2 squared, which gives me 4. So if you're going to show all your work, this would be rewritten as x squared minus 4x plus something equals negative 9 plus something. The something I'm going to add to make it a perfect trinomial, which then makes it factor into a perfect square, is going to be the second number here. So 4 and 4. This would equal negative 5. This trinomial here will factor to negative 2, so x minus 2 squared. Take the square root of both sides. X minus 2 equals plus or minus, this is negative 5, so it's going to be I square roots of 5. Add the 2 over, x equals 2 plus or minus I root 5. Going to do E now. E. So 4 divided by 2 squared equals 2 squared, which equals 4. So x squared plus 4x plus something equals negative 6 plus that something. So this here is going to be the value of 4 and 4. This factors down to 2, so x plus 2 squared. Remember we were picking the perfect number to add to the trinomial in order to make it factor down to a perfect square equals negative 2. Square root both sides. X plus 2 equals plus or minus I square roots of 2. The reason why it's I is because it's square root of a negative number. I makes that imaginary part come out so we can have a square root of 2. Subtract 2 on both sides. X equals negative 2 plus or minus I root 2. So that is when you're solving by completing the square. The other way that we use it is to convert into vertex form. So converting into vertex form is something that I didn't talk about in all classes on Friday, so we will be doing this in class as well as the examples that I've not covered yet. Converting vertex form, I need to still set up everything like I did before, but I'm just not going to solve, and I'll show you what that looks like. So switch these two numbers, x squared minus 9x equals negative 18. So I'm going to take negative 9, divide it by 2, squared. Can't really simplify this, so I'm going to leave it at that. That's going to square both of these is going to equal 81 over 4 because it's a negative. So I'm going to add an 81 fourths to both my equations. So x squared minus 9x plus the magic number that I just found, 81 fourths. To both of those, this left side factors to x minus 9 halves squared equals, and I'm going to do this part here on my calculator. So on my calculator, I'm going to go negative 18 plus 81 divided by 4. I'm going to hit math frac. And we get 9 fourths. Now normally we would solve this, and since this comes out to be a pretty number, if you take square root of both of them it wouldn't be hard, but since we're just writing vertex form, I need to move this back over because I want it to be in the form of x minus h squared plus k. So I need to move this back over. So this would be x minus 9 halves squared minus 9 fourths equals y, and the reason why we put the y there is because it's a function. So solving the other equations, so if we're going to be solving by completing the square, we have to divide out the a values, which is different than when we actually convert to vertex form. So what we're going to do first is we're going to take everything and divide it by 2. So divide everything by 2. I'm going to have x squared plus 3x minus 6 equals 0. Once again, we're solving. So then my magic, x squared plus 3x plus something is going to equal 6 plus something. So 3 divided by 2 squared equals 9 fourths. So that magical number I'm going to add to both equations is 9 fourths. So this will factor down to x plus 3 halves squared equals, and once again on my calculator I'm going to do 6 plus 9 fourths, so 6 plus quantity 9 divided by 4, math frac, gives me 33 fourths. So now I'm going to take square root of both sides. So now I'm taking square root of both sides, I'm going to get x equals, or x plus 3 halves equals plus or minus the square root of 33, because I can take the square root of 33 and get square root of 33. Square root of 4 is 2. So now, this equation here, I'm going to get x equals negative 3 halves plus or minus the square root of 33 halves, and just be done with my math there. So what I'm going to do is I'm going to come up here to this one here. This one is a lot uglier, so that's why I'm doing it last. Divide everything by 2. X squared minus 7 halves x equals negative 5 halves. So I'm going to, excuse me, take x squared. Excuse me, I'm going to take the negative 7 halves, so negative 7 halves, divide that by 2, squared, and in my calculator that's going to get me negative 7/4. Squared, which is going to give me 49/16. And so my equation, the magic number I'm going to get is x squared minus 7 halves x plus 49/16, as well as negative 5 halves plus 49/16. So factor that out, x minus 7/4 squared equals negative 5 halves plus 49/16, math frac, gives me 9/16. Square root both sides. X minus 7/4 equals plus or minus the square root of 9/16. Both of these are perfect squares. So x minus 7/4 equals plus or minus 3/4. X equals 7/4 plus or minus 3/4. Since they both have the same denominator, 7 plus 3, x equals 10/4. And 7 minus 3, 4/4. Simplifies down to x equals 5 halves and 1. And that would be your solutions. Vertex form, I will leave till in class, and I will make a special video about this. This is a lot trickier, and we have to do a lot of factoring, and I'm not going to do that right now because I will do that in class, and then I'll make a video tomorrow.